Hello. In this section, we are going to give a brief introduction to chromatography. Chromatography is one of the most important analytical methods used in the pharmaceutical industry. It is used for the separation and identification of different chemical compounds in dosage forms. So in the previous section, we have discussed what is the main principle of chromatography, and we have discussed thin layer chromatography. In this section, we are going to discuss column chromatography. Okay, so what are the practical steps for preparation of a column chromatography in a burette? First, we are going to add a plug of sand and cotton at the end of the burette, prevent any solvent from dripping down. And then we are going to prepare in a beaker a slurry of silica dissolved in the eluent, and then filling the burette with the slurry containing the silica or the stationary phase. We are going to allow the mobile phase to move down and open the tap a little bit so that any excess of the mobile phase will be eluted. Okay. Next thing, we are going to load the sample. The sample here is a mixture of dyes consisting of methyl red and fluorescein, a mixture of dyes. The sample will be applied at the top of the column, and then, according to the different affinities of the dyes to the stationary phase and the mobile phase, it will move down the column. The dye which has more affinity or is more soluble in the mobile phase will move faster down the column and will be collected first. The dye which has greater affinity to the stationary phase and less affinity to the mobile phase will be retained on the column and will move very slowly and can be collected later. Okay? So this is how the column will look like during the separation. So this dye has more affinity to the mobile phase, so it's moving faster, and this dye has more affinity to the stationary phase, so it's retained for a longer time.
This video outlines a method for carrying out column chromatography. You may be given slightly different instructions when you do this in the lab, but the principles will be the same. First of all, a small piece of cotton wool is placed in the bottom of the column to prevent solid material from going into the tap. Different columns may have different types of tap, but obviously the idea will be the same. Next, a small amount of sand is poured in to a depth of about 1 centimetre. Here you can see the sand forming a level surface on top of the cotton wool. We then take the appropriate amount of silica in a beaker, and this is then made into a slurry using the solvent we're going to run the column with. This solvent is known as the eluent. Here you can see us swirling the silica with the solvent before pouring it into the column very carefully. Again, a funnel should be placed in the neck of the column to assist with pouring. And you will need to occasionally swirl the beaker to ensure that the silica doesn't settle out in the bottom of the beaker. Where appropriate, more eluent should be added to reform the slurry to assist with pouring. You may need to do this several times. Should the level of the eluent get close to the top of the column, then some of it should be removed by opening the tap. We can run this into the beaker, which will then assist us in making a slurry with the remaining silica. And finally, we've transferred all of our silica into the column. Now we need to run some of the eluent out of the column so that it comes down to the level of the silica. It's crucial that you don't allow the silica to run dry, so you need to keep a close eye on the level of the eluent and close the tap at the appropriate moment. Here you can see we've run the eluent down to the correct level so that the top of the silica has not dried out. The next stage is to load our crude compound onto the column. First of all, we need to dissolve it in a small amount of the eluent. It's important to ensure that all of the crude compound has been dissolved. And then the resulting solution can be added to the column using a glass pipette. Here you can see the solution is being added evenly around the sides of the column. Now we add some sand to a depth of about 1 centimetre on the top of the column. This will protect the silica as we add eluent. And here you can see us topping up the column with eluent. And we're now ready to run our column. So we open the tap at the bottom of the column, and this allows us to collect our first fraction. In this case we're collecting the fractions in test tubes, but depending on the size of your column you may use sample vials or even conical flasks. Once collection is complete, we can close the tap momentarily to move on to collect fraction number 2. And this process can be repeated any number of times to collect as many fractions as are required. Because our compound is coloured in this case, we can actually see it moving down the silica. This will give us a good indication as to when it's actually eluting from the column. In cases where you can't see the compound because of any colour, you can use TLC to analyse the fractions to identify the presence of different compounds. And as the level of the eluent approaches the sand, it's important to make sure that you top it up. We can then continue to collect fractions, and in this case you can see that the yellow band in the silica is approaching the bottom of the column. If we look closely at this particular fraction, we can see that the solvent has a yellow colour, telling us that our compound is eluting. Of course, in other cases, as mentioned previously, you'd have to use TLC to identify the presence of the compound. And here we have a full set of fractions. We can now collect any compounds that are present by removing solvent, and this would most commonly be done using a rotary evaporator.
Okay, this figure shows the column during the elution process. At the beginning, all the sample is loaded at the top of the column. During the elution, dyes which has more affinity to the mobile phase, which is in this case the green dye, will move faster and further than the red dye, which is retained more in the stationary phase, and hence the green dye will be collected first, and then the red dye. So we have started with a mixture of both dyes. After the chromatographic separation, the two dyes were easily separated into two different components. So packing the stationary phase into a burette is the simplest form of column chromatography. There is another advanced form of column chromatography in which the stationary phase is packed into a stainless steel column, which is placed in an automated instrument known as HPLC, or high performance liquid chromatography. In HPLC, the sample is injected into the column, and then the mobile phase is pumped over the sample, and then according to the different affinities of the components in the sample to the mobile phase and the stationary phase, the different compounds will be eluted. Components having more affinity to the mobile phase will move faster and will be first detected by the detector. Okay, so this is the first component detected by the detector. Okay, components having lesser affinity to the mobile phase and more affinity to the stationary phase will be retained more and hence will appear later on the chromatogram. Okay, so chromatography is basically an instrumental technique for the analysis of mixture for the purpose of either separation and determination of the different components of a mixture. Thank you.